Good day, students, scholars, and curious viewers. My name is Mr. SKT, otherwise known as the Super Kuroichi Teacher. In this video, we're going to be completing our section of laws of exponents with not another law, but an interaction with a very special group of mathematical numbers or symbols, whichever you call them. In today's lesson, we're going to see every law's interaction with fractions, because you would have noticed we had a disturbing lack of fractions throughout these videos. Well, today this is where I brought them. I've corralled them all into one space to have them shown in one video. Without further ado, let's get started. So these are the interactions of fractions with every law of exponents. Starting with its interaction of law 1, how do fractions multiply? So here I have an example of x to the 2 divided by y times x to the 3 divided by y to the 2. The most important thing to know here is that numerators multiply by numerators, denominators multiply with denominators. That's something that you should know already regarding fractions, especially for those who are grade 9 level and up. So that x to the 2 multiplies with the x to the 3 is going to give you law number 1. When you multiply, you add the exponents, so that should give you 2 plus 3, x to the 5. And then y, which is, remember, y to the 1, y to the 1 times y to the 2 will give you y to the 3. So you end up with a final answer of x to the 5 divided by y to the 3. And that's a simple interaction of law 1. Nothing too bad. But of course, this law tends to get mixed with a lot more others. In fact, that's the majority of the questions. Them mixing. And when I say them, I mean like the Department of Education or your teacher or the examiner of the exams in which you are writing. So they will tend to mix different laws together in order to test your array of knowledge and your application of the different laws. So these next examples are going to see law 1 and 2 being put into use. Remember, law 2 was based on division. So here I have x to the 3, y to the 6, all divided by x, y to the 3. And that's times x to the 7, y to the 10, all over x to the 11, y to the 4. Now, by the arrows, as you can see here, there are two ways that I know of. Well, when I say I know of, I mean two ways that are best for doing this kind of puzzle, this kind of problem. So let's go to the right to start off with, and when I say the right method, I mean the method to the right, where you are just doing the multiplication first. So you are multiplying the x's on the numerator, the y's on the numerator, the x's on the denominator, and the y's on the denominator. So on the numerator, you would have x to the 3 times x to the 7 giving you 3 plus 7, x to the 10. Y to the 6 times y to the 10 will give you y to the 16. X to the 1 times x to the 11 give you x to the 12. And y to the 3 times y to the 4 giving you y to the 7. So now that you've turned it all into one fraction, now you can do the division part. And if you remember, the easiest way to do division, because division uses subtraction. Do the bigger number minus the smaller number, and then find out which one it's bigger at. So you have an x to the 10 and you have an x to the 12. 12 minus 10, x to the 2. Where is it bigger? It's bigger at the bottom, so you should have x to the 2 at the bottom. Y to the 16, y to the 7. Do a 16 minus 7, which gives you y to the 9. And where is it bigger? At the top. So you should have final answer y to the 9 over x to the 2. And that's how to do that. The other method that I can at least suggest is doing the simplifying each of these first. So here you have x to the 3 divided by x to the 1, which will give you x to the 2. And y to the 6 divided by y to the 3 turns that into x to the 2, y to the 3. Here you have x to the 7 over x to the 11. That's going to give you x to the 4 at the bottom. And y to the 10 divided by y to the 4 gives you y to the 6 at the top. And then from there, you just multiply them up. There's no other x with the numerator, so the x squared just follows suit. Y to the 3 times y to the 6 gives you y to the 9, and there's no other x to the 4 at the bottom, so it follows suit. But in the end, you still need to sort those two out. So 4 minus 2, giving you 2. And where's it bigger? At the bottom. So you end up with x to the 2 at the bottom. And as you can see, two different methods, but you get the same answer. So that's an example of division and multiplication, but let's do another one. Let's do another example, but made a little trickier. So the original question here was x to the 4 divided by y to the 5 divided by y to the 6 over x to the 3. Now you notice that I circled the division by y to the 6 over x to the 3. That's because you don't really want division signs when you're simplifying these algebraic expressions. You notice that we've been keeping it with multiplication signs. Multiplying makes it easier. Now with division, on the other hand, what you want to do if you don't think you can divide straight up, then you're dividing by a fraction. So that means when you divide by a fraction, you flip the fraction that comes after the division sign and turn it into multiplication. So y over 6 over x over 3 becomes x over 3 over y over 6, and then that division becomes multiplication. Now that looks a lot easier to work with, doesn't it? And from there you just go x to the 4 times x to the 3, giving you x to the 7, and then y to the 5 times y to the 6, giving you y to the 11. And you're done. And that's the second one. Next, the fractions interaction with law 3. Law 3, when you raise a thing by an exponent. So an example is a to the 2, b to the 3, all over c to the 5, and that whole thing is raised to the 4. Remember when I said that for law 3, everything inside that bracket gets hit with that exponent? Same thing. Every single thing. So that a to the 2 is raised by a 4, giving you a to the 4 times 2, giving you a to the 8. B to the 3 raised to the 4, giving you b to the 3 times 4, giving you b to the 12. And then c to the 5 raised to the 4, c to the 5 times 12, 5 times 4, giving you 20. And that's your final answer. Don't worry, we have 3 more left. Right. So the next one is law 4, when you raise something to the power of 0. Anything raised to the power of 0 equals 1. And as a result, any fraction raised to the power of 0 equals 1. I just noticed that I lost a lot of natural light now. If you're living in South Africa, know that we get hit with load shedding every now and then. But anyway, I will not let anything come in the way of my students. Right now, so here I've got a situation where it's a to the 0 divided by b. Since only that a over there is being raised to the 0, oh my god, that's so much better. Only that is going to turn into 1. The b, nothing's happening to it. It's fine. So you can round that up by saying the whole thing equals 1 over b. And that's practically what happens with law 4, raising to 0. Law 5, negative exponents and fractions. Here's my example. I've got, no, that's just the next door stock. Okay, so I got a to the 2 over b to the 3, and all of that is raised to the power of negative 2. So there's two different ways that you can sort this out. The one method that I would suggest is do your law 3 like you would normally. So subject each of those to with that exponent. So you get a to the 2 times negative 2, which gives you a to the negative 4. And then you get b to the 3 times negative 2, giving you b to the negative 6. And from there, remember, if you have a numerator with a negative, it becomes a denominator with a positive. And if you have a denominator with a negative, it becomes a numerator with a positive. And that's the method. That's how you would do that. Your final answer there will be b to the 6 over a to the 4. Positive exponents. The other method that is widely suggested is do the flip first. You see, what you can do is actually do that, the actual negative exponent law, where you do the flip before you put it into the exponent via law 3. So here, in order to turn that from negative to positive, the fraction got flipped. B went to there and a went to there. So it's already flipped, and now you just have to do law 3. So b to the 3 raised to the 2 gives you b to the 6. And then a to the 2 raised to the 2 gives you a to the 4. And you notice the same answer. Two different methods, same answer, both of them equally valid. But do remember, only those that have been raised to a negative will move. So in this example, only the A, the C, and the D will move to the other side because each of them are raised to negatives. So the B to the 3 and the E to the 3 still remain where they are. The A to the 2 is going to move down to a to the positive 2. The c to the 1 is going to move down, becomes c to the 1. And the d to the negative 2 moves up and becomes d to the positive 2. And from there you can just arrange it in alphabetical order. You know, because of the grammar of algebra. And that leaves us with law 6. What happens to fractions when you try to root them? Well, basically it's the same thing that happens when you try law 3. It affects both numerator and denominator, and everything in that numerator and denominator. So if you have the cube root of x to the 12 over y to the 27, you're gonna have to do law 6, which is divide the exponents. So you're gonna end up with x to the 12 divided by 3 over y to the 27 divided by 3, thus giving you x to the 4 over y to the 9. Whew. And that's the fractions interactions with the law. But now I have a special treat for y'all. One big exercise. But do not worry, students. This exercise is not that hard. This exercise is simply to help you grasp everything that you've done in this lesson. So I'm going to scroll through it very slowly to give you an opportunity to like pause and take it down should you need to. Remember, the instruction is simplify, leave answers with positive exponents. So let's slowly scroll down so you get a decent image, a decent feel for what kind of questions that I have set for you. Yes, you would notice that a majority of them are based on what we've done in this lesson. Okay, with that being said, now is the opportunity. If you wish to do this by yourself, please pause the video. You have this opportunity in 3, 2, 1. Right. With that being said, let's now do the correction. Right, so the first one, we had a to the 4 over b to the 2 times a to the 3 over b, which remember is b to the 1, times a to the 5 over b to the 3. This is testing law number 1, so it's just multiplication. You add the exponents of what you can. So you're going to end up with a to the 4 plus 3 plus 5, which gives you a to the 12, over b to the 2 plus 1 plus 3, which is b to the 6. Done. Next, I'm going to try and go as fast as I can to get so we can cover it at a decent pace. F to the 3, g to the 2 over h times f to the 6 over h to the 3, then divide by h to the 4 over g to the 5. The first thing you would want to do is sort out that division sign. You do not want to see a division sign. So the fraction that comes after the division sign, you change that, you flip that. You flip that and then turn it, and then turn the division into a multiplication. And I actually wrote it below that. So as you can see, we have that one remained the same, that one remained the same. However, the g went to the top and the h went to the bottom, and we changed the division to a multiplication. And now we can sort this out normally. So at the top, we have f to the 3 divided by f to the 6, which gives you f to the 9. G to the 2 divided by g to the 5, which gives you g to the 7. And then h to the 1 divided by times h to the 3 times h to the 4, giving you h to the 8. Okay, and that's number 2. Number 3, I decided to be a little cruel, and I put 2 divisions. So I have x to the 7, y to the 9, divided by y to the 2 over x to the 6, divided by y to the 4 over x to the 8. Each fraction after a division sign, you can, as I do it, put it in its little block. So you know that is to be sorted out. That needs to flip and then become multiplication. So that's y to the 2 over x to the 6, switch and turns into x to the 6 over y to the 2, as long as that becomes multiplication. Y to the 4 over x to the 8, switch, become x to the 8 over y to the 4, multiplication. Now it's all multiplication, now you can sort all of it out. X to the 7 times x to the 6 times x to the 8, add all them up because it's law 1, giving you x to the power of 21. And then y to the 9 times y to the 2 times y to the 4, add all them up, it will give you y to the 15. Number 4. Number 4 is 3 x to the 4, y to the 5, all over z to the 8, and all of that is being squared. So this is law 3 that we're dealing with. So law 3, everything is going to get affected by that exponent in the outside. The 3 is going to square and become a 9. The x to the 4 is going to raise to the power of 2, x to the 4 times 2, giving you x to the 8. y to the 5 raised to the 2 gives you y to the 5 times 2, giving you y to the 10. And then z to the 8 raised to the 2, 8 times 2, giving you z to the 16. And that's number 4. Number 5. A to the 3 over b to the 2, all of that is raised to the power 3. Divided by a to the 2 over b, all that's raised to the 5. BoardMass will tell you to do the exponents first. And therefore, that's what we're going to do. So, law 3 is going to turn the first one into a to the 9 over b to the 6. Then, law 3 is also going to turn the second one into a to the 10 over b to the 5. Now with that sorted, we have a division by a fraction to do. Switch and turn into multiplication. So the b goes on top and the a goes to the bottom. So you have a to the 9 over b to the 6 times b to the 5 over a to the 10, giving you a final answer of 1 over ab. Why 1 over ab? Well, you have a to the 9 times over a to the 10 effectively. 10 minus 9 gives you a to the 1. Where is it bigger? At the bottom. So there's your a to the 1 at the bottom. You have a 5 and a 6. Where is it bigger? At the 6. 6 minus 5, giving you b to the 1, also at the bottom. And there you have. And then what goes at the top? A 1. Number 6. S over k to the power 0 times s to the 0 over k times s over k to the 0. This whole thing becomes 1. This part becomes 1, and this one becomes 1. So you effectively have 1 times 1 over k times 1 over times s over 1. All in all gives you s over k. 7. X to the 5 over y to the 7, all raised to the negative 3. You're doing essentially the law 3, so you're going to end up with x to the 5 times negative 3 is going to give you negative 15. Y to the 7 times 3 give you negative 21. And remember, when they are negative, they switch position, giving you a final answer of y to the 21, positive 21, over x to the positive 15. Number 8. Number 8, you have a to the 3, b to the negative 2, and normal c, all over d to the negative 3, e to the 4, and all that's raised to the negative 4. Since this is an exercise, I'm not going to show multiple methods. What I'm going to do is I'm going to go with what I feel is the easiest method because, oh no, you probably want to see the answer. So, what I did was I just did basic law 3 over here. And from there, I got a to the negative 12, b to the positive 8, c to the negative 4, d to the positive 12, and e to the negative 16. And you see all those that I circled? Those all have negative exponents now. So those are going to be moving. So you're going to end up with, now you notice that the b and the d remained where they were. The a moved down, becoming a to the 12. The c to the 4 moved down, the c to the negative 4, moved down and became c to the 4. And the e to the negative 16 moved up and became e to the 16. And then finally, my throat. Square roots of a to the 4, b to the 6, all over x to the 10, times the fifth root of x to the 100, a to the 45, over b to the 60. Step 1, do the roots first. BoardMass tells you do the roots first. Although it doesn't strictly tell you in the BoardMass part, but that's the the exception. That's what the O for other in board maths means. I know some of you are going to say it means of. Yes, it does, but it also means other in some other civilizations. And I like that. And I personally like it like that. But anyway, anyone would tell you the roots come first. So, when you square rooting, which means each of these are going to be divided by 2. So you're going to get a to the 2, b to the 3, x to the 5. And each of these, and times, each of these are to the 5th root. So that means each of these are going to divide by 5, giving you x to the 20, a to the 9, and b to the 12. And then from there, you can just multiply them like normal. So you get a to the 2 times a to the 9, giving you a to the 11. B to the 3, x to the 20, and then all over x to the 5, b to the 12. Sort out what you can, the b's and the x's. The a to 11, there's no other a there, so it just follows suit. It does not care. The b to the 3 and the b to the 12, on the other hand, you have division over there, so b to the 3 divided by b to the 12. 12 minus 3 gives you b to the 9. Where is it bigger? At the bottom, so you would have b to the 9 at the bottom. And then you have x to the 20 divided by x to the 5. 20 minus 5 gives you 15. Where is it bigger? At the top. So your final answer is going to be a to the 11, x to the 15, all over b to the 9. With that being said, I think we can conclude this section on laws of exponents for now. But everything that we've done so far should help you throughout your GET phase of mathematics regarding the laws of exponents. If you enjoyed this content, please leave a like. That will help me towards getting trending. Share and subscribe and share this video. Help assist me with increasing my chance of getting monetized. And please comment on what you want. Comment on what you want to see next. It will give me direction. But also comments on anything that you want me to possibly explain further. I do want to see. The more questions I see, the better. That's what helps education flourish. With that being said, I'm out of words right now. I need to rest my throat for a bit. That's Mr. SKT, the Super Kuroishi teacher. And please, through South African load shedding, have a nice night.